All right, so we can just kick it off then. Welcome everyone. We're assuming that you got here through one of two ways, either because you are registered for the Foundational Open Science Skills Workshop that we are starting next week. And this is one of the pre-FOSS workshops to sort of get you up to speed on Unix before we start that workshop. Or you came here from AG2PI. In either case, welcome. We're glad to have you here today. I'm just going to do a brief sort of rundown of the structure of delivering this Zoom workshop, and we'll get you up to speed on just what you should have open, make sure everyone has everything that they need set up and installed, and we will go from there. So I'm going to put into the chat here a link to a HackMD page. So HackMD is a like Google Docs-ish, but it uses Markdown, which is a sort of lightweight language that lets you format text. It's both readable when you're writing it, but it formats into this nice, pretty-looking thing. So I'll share screen briefly to show you what that looks like and show you how we're going to use that. So share screen. Okay. So here we go. Yeah, so we've got this on the left-hand side. When you open up this link, you should have up here, you'll have these options. So you can either just view the editor and the sort of created thing, or just the output. But we'll keep it open like this. So we've got some information here for all of you on just the link to the lesson we're going to be teaching itself, the Zoom link in case you get lose that for some reason, and then we down below, one of the main things we'll have you do is interact with a questions and comments section. So the Zoom chat can be kind of annoying to use for general questions and comments because I don't know, like you can save it at the end, but it never is formatted quite nicely. So for general questions you might have where maybe you want to learn something more, or you have sort of a, just out of curiosity type of question, you can ask that in the questions and comments section here. So the way we'll have you do that is type it out as a bullet point like this. So I have a question about something, and then one of the instructors we will pop in and we will add as a sort of sub bullet point, hi, I have an answer about it. So we'll format it like that. That way everyone else can easily, you and everyone else can find those questions and answers to them, and hopefully this will be sort of a collaborative place to ask and answer questions. We will also, we've got some content down here for next steps, things that we think you could do next after we're done today, and just useful resources we'll put down here. Now, one main thing is this should have gone out in the pre-workshop email for this workshop. You should have been sent to this page to look at the instructions for setting up this lesson. If you have not done this, please go ahead and follow the instructions here. So for this lesson, we will need to download a zip file and then unzip or extract that file. That'll have a folder with all of the data and files that we'll need for the lesson. You can go ahead and put that on your desktop so that we're all working in the same place. So we'll so we'll all be working in the same place from that folder on our desktop. We'll also need to be able to use a shell, which we'll talk about what that actually means in a little bit, but on a Mac or Linux computer, you should already have that installed and have access to it. So on a Mac, you can look for the terminal application and open that up. On Windows, it is a touch more work. You will have to install Git for Windows. That's the easiest way to do it. You can, again, follow the instructions, follow the links here to get that done. If you have difficulty, if you haven't done this yet and have difficulty doing it at all, feel free to message one of the instructors. So whoever's not currently chatting, you can send them a message directly on Zoom. Will probably be the easiest way to do that. So we want to reserve the HackMD for sort of broader questions. If you have specific help that you need, we would like you to message one of us directly. All right, Ryan, anything else we should add here?
I just put this in the chat, but I just wanted to let everybody know that this is being recorded, and this will be put on the Agricultural Genome to Phenome Initiative website as part of their workshop series. So we've combined forces with the USDA Institute, AG2PI, and Cyverse, and the Carpentries to bring this Unix Shell lesson to you all. So this is a kind of a 3-organization partnership to bring this all to you today. So if you get stuck at any point, get lost, it will be recorded. You can go back to the point where you got lost and start over and try and work through the examples.
Yep. All right. So with that, I think we'll actually get things started for the day. So we will start off by, I'm going to chat a little bit briefly, just sort of some intro stuff, and then we'll actually get to working in the terminal. All right. So just going to provide you a little bit of background, sort of why we want to teach these types of skills to you. Why are we spending time, taking 3 hours of your day to talk about the Unix shell? Well, humans and computers, we interact with computers in many different ways. Like, you're probably familiar with using a keyboard and a mouse, maybe a touch screen interface, or something like a speech recognition system. But far and away, the most widely way that we interact with computers is what we call a graphical user interface, or a GUI. So when you think of like an app on your computer or an app on your phone or tablet or something like that, that's a graphical user interface. There are graphics, we interact with them and achieve a set of tasks. We typically are, in that case, giving instructions to the computer by clicking with a mouse or typing something with our keyboard. And while these GUIs are often very interactive, easy to use, and intuitive to learn, they typically scale quite poorly as a way of delivering instructions to our computers. So like something that you need to do 1,000 times, like if you need to pull out the first line of 1,000 different files to do something, doing that pointing and clicking, like copy pasting, that is going to take you a lot of time. What we want to be able to do is we want to be able to automate that. We want to be able to make that something that we can let the computer do. Computers are very good at repetitive tasks, and the more we can offload that from our own work to them, the more time we're going to save and the less error prone these tasks are going to be. So this is where the Unix shell comes in. So Unix shell is a command line interface, which we'll kind of touch on what that means a little bit. And it's a scripting language. So we can write out instructions into scripts that we can carry out multiple times. It allows us to take repetitive tasks and do them automatically and quickly. So with proper commands, the shell can repeat tasks with or without modification as many times as we want. Using the shell, we can get a lot of these tasks done far, far more quickly than we possibly could pointing and clicking. So there's a lot of jargon getting tossed around, and we're going to do a little bit of work to clear some of this up. So the shell. The shell is a program where we can type in commands. It's a way for us to interact and give instructions to the computer. So it's possible from the shell to invoke complicated programs, like you could use a climate modeling software, or very simple commands to create like an empty folder with one line of code. So you can do a lot from the shell, from very simple tasks to very complicated ones. The most popular Unix shell, so Unix refers to a type of operating system that sort of underlies a lot of operating systems we use today. The most popular one is called Bash, which stands for the born again shell. Bash is the default shell on most modern Unix computers and most packages that provide Unix tools for Windows. So Bash is sort of the default out there. Now, using the shell can take time and effort to really learn how to do well. A GUI, a graphical user interface, will present you with choices to select. Typically with a command line, choices they're not automatically presented to you. And that means you have to learn a few commands, like sort of learning new vocabulary in order to really interact with it. However, unlike a spoken language, a small number of words or commands can get you a long way. And we'll really only cover a few core commands today, but we're going to get you comfortable using them and using them together to interact with and use the Bash shell. So additionally, another benefit of using this is that the command line is often the easiest way and sometimes really the only way to interact with remote machines and supercomputers. So if you need to utilize a cloud computing platform, your high performance computing cluster at a university or institution, it's often the only way you're going to be able to do that. So familiarity with the shell is basically essential to run a variety of really specialized tools that you may need to use as you do your research. And as these cloud computing methods, as they become more and more popular, more and more common, being able to use the shell is just becoming more and more necessary. So we're going to cover some very basic skills to use the shell. We're not going to necessarily get you doing high flying work right off the bat, but building a firm foundation that you can then build your more specific skills off of. So now we're going to actually open up a shell. So the way we'll do that is there's instructions in the setup should tell you how to open up a shell for Windows and how to get the Git Bash program open. On Mac, I'll show you how to do that. I'm on a Mac. On Linux, it's sort of specific to your flavor of Linux, but you want to open up a terminal application. So Mac, I'm just going to open up the terminal application and I will screen share what that looks like for me. All right. So this is what I'm greeted with when I open up the shell. So I see this little Bash 5.0 thing. You may or may not have that. You may have a slightly different looking prompt may appear when you open it up. Mine shows this, but it will likely end with this $sign. This $sign is what's called a prompt. So the prompt is sort of like a prompt, like, hey, we're ready for you. The shell is ready for you to type something. So when you see commands, when we show commands, you won't type any of this part. You will just type out what comes after the prompt. So the prompt is followed by this text cursor. So on mine, it looks like this, this solid gray bar. Yours may be this flashing bar. It could be an underscore or maybe like a just vertical line cursor. But that's indicating where your typing is going to appear when you're typing into it. So we are going to try out our first actual command. So the command is ls, which is short for listing. And this command will list out the contents of my current directory. So if I run this, I see a bunch of different stuff. I can scroll through this. So I'm scrolling and this is kind of everything I've got going on. We see some photographs, folders, we see a bunch of different stuff. But this is the output we're going to see. If you mistype something, for instance, like if I typed chaos accidentally, and the shell can't find a program whose name matches what you typed, it'll give you an error message like this: command not found. So this is frequently going to happen when you have typos. So often worth going back and checking. If you see this error, make sure you type things correctly. So this is just a way to show you, we're just kind of showing you how to interact with the shell, typing in commands, pressing enter or return, and you get some output back. Now, we're gonna work through an example using that data zip folder, that zip file that you downloaded and unzipped. We have that open. We have that on our desktop now. So we're going to work through sort of an example problem. So the sort of motivating example here is imagining Nell Nemo, a marine biologist, has just returned from a 6-month survey of the North Pacific Gyre, where she's been sampling gelatinous marine life in the Great Pacific Garbage Patch. She has 1,520 samples that she's run through an assay machine to measure the relative abundance of 300 different proteins. She needs to run these 1,500 some files through an imaginary program called goostats.sh that she inherited. Her advisor gave us to her. On top of this huge task, she has to write up the results by the end of the month so her paper can make it to submission on time. But the bad news is that if she has to use this script and run it by hand using a GUI, that will mean selecting and opening an individual file 1,520 times. Now, if she can, get this to 30 seconds per file, which is like pretty quick pointing and clicking, that'll still be about 12 hours of work in total. Now, I don't know about you, but pointing and clicking for 12 hours, very likely to make a mistake, and it's just not how I want to spend the day. So with the shell, instead, Nell can assign her computer this mundane task while she focuses on writing her paper. So we're going to go through a few ways that Nell can achieve this. So basically, this whole lesson sort of tracks through this whole process. Today, we're going to focus on the components, the episodes of this lesson that cover navigating to files and directories, creating files and directories, checking lengths of files, doing some basic tasks on these files. The things we're not going to cover from this lesson, just due to time constraints, are going to be things like iterating to do the same process many, many times for a given file, for a set of files, or creating scripts to do these many different times. So we're going to forego those couple portions, but they're still in here and they still follow this same basic lesson structure. So we'd encourage you to, if you're interested, you can follow along with the lesson content on your own afterwards. So now we are going to move on to navigating files and directories. So the part of our operating system that's responsible for managing files and directories is called a file system. So this organizes our data into files to hold our information, and into directories, which we also call folders, which hold these files or even other directories, right? So one thing about working with the shell is that we have to become a little more familiar with our file system and how our computer actually organizes files and folders into these structures. That's going to be more important maybe than when you're using a point and click interface to work with files and folders. So one of the most important things we might want to do is just figure out where we are right now. So I ran ls just to show you, and what came out was a bunch of stuff, but where do all of these files and folders actually live on my computer? Well, we can run a command called pwd, which stands for print working directory. So if I type that out and hit enter, we see where I currently am is users MJ. MJ is the name of my user on my computer. So directories are like places, locations where at any given time we're using the shell, we're in one place, which is called our current working directory. So commands typically will read and write files in the current working directory, which we might say like here, where are we? We're here. That's where things are going to happen. So knowing where you are before running a command is very important. So we're in my home directory right now. Now, there can be some variation in how home directories look. So the way mine looks here is pretty typical to a Mac or Linux computer. On Windows, it might look something like C:, and then / something. So it might look a little different in different versions of Windows as well. So if PWD for you returns something different, then you may need to navigate to your users folder using the CD or some other commands. Some other commands we covered won't work correctly. So if you have an issue and you ran this and it didn't open to your user, just let someone know in the chat and we'll try to get that sorted for you. But so understanding what our home directory actually is, we kind of have to look at how our file system as a whole is organized. For the sake of this example, I'm gonna screen share and I'll show you, there's some nice graphics for this on looking at this example of how this fictional scientist Nell has their file system organized. So I'm going to switch my screen share. All right, so on Nell's computer, the file system looks like this. So we often represent file systems like this as these sort of tree diagrams, these branching diagrams. So at the very top is this root directory, which is typically referred to with a / character on its own, which is why that /users Nell starts with the / same thing with my when I printed my working directory in my computer, it was /users/mj. So inside our root directory are several other directories. Bin is one that often holds some built-in programs, data for some miscellaneous data files, users where each user's personal directory is located, and then TMP, which stands for temporary, for files that don't necessarily need to be used or stored long-term. So we know that users/Nell is stored inside this /users because it's part of the name. So what we get back is called a path, which describes the whole sort of from the very top of the computer, the root directory, all the way down to where we are. So the path will be sort of slashes separating each level of this. So if we actually, carry out this graphic, we see that inside users, we have a directory for each person, each user with an account on Nell's machine. So her colleagues, in this case, Imhotep and Larry. So we have Imhotep, Larry, and Nell here. And those paths to get to theirs would be similar. It would be /users/Imhotep for Imhotep's home directory. And same thing for Larry. So these familiarity with these paths, with directory and file paths, is going to be key in helping us to navigate these file systems effectively. So we can run, we'll switch back to actually working in the shell again. So I will switch us back to sharing this part. All right, so now we can use ls again. Now that we know a little bit more about where we are, running ls maybe tells me a little bit more. So it says inside my home directory, I have all of this different stuff. So I've got a bunch of different things going on in here. ls will print the name of all of the files and directories in the current directory. So we can kind of help make this a little easier to read by using options which are also known as switches or flags that change the way that these commands behave. So we can use the capital F flag, which will tell ls to classify the output by adding a marker to the files and directory names to indicate what kind of thing they are. So a slash at the end of one of these names will indicate that it's a directory, an @ indicates a link, and an asterisk will indicate an executable, which is something we don't need to worry about right now. The way we'd use this flag or this option would be to type out ls and then space and then dash capital F. So if I hit enter to run that, now you can see the output looks fairly similar, but there's a little more information contained here. So I can see that all of these folders now end with a slash, which tells me that they're a folder. We can see things that don't end with that are files, like these JPEG files. And then I even have some executables, like a Python script here. So depending on the default options, your shell might color these as well. Mine is not set to give me any nice colors, but you can change shell options typically to show when things are printed out, different colors indicating if something's a folder, a file, what have you. So let's see. One thing to note, if you are sick of the clutter on your screen like this, you can type out clear and hit enter, and it will it'll just clear off your screen. You can still scroll up to see stuff that you've done before, but kind of nice occasionally for visual sake. Oh, one other thing I forgot to ask, but if anyone has trouble reading the size of the font I have on my terminal here, let me know and I can increase the size a little bit. If you'd like that, just you can put that in the chat. All right. So the ls command has a lot of other options. Generally, it's useful to, before you start using a command, figure out a little bit about what some of the options are for it. So there are two general ways to access this. So we can do ls, and then we can actually give it an option called help. So we do -- help. So typically when we're passing these commands or these flags, you would do _ followed by some sort of abbreviation, like a capital F. And when it's 2 dashes, it'll usually be a whole word or series of words spelled out. So that's why it was 1 _ for -f and 2 dashes for -- help. So if we run that, we get this sort of help page, this output that tells us a bunch of the different options. So all Unix commands will have this same basic structure where you get a little usage, we get sort of a description of what it does, and then we have a bunch of arguments with descriptions of what they are. So we can see here, you know, our different flags can change a lot of different things about the way the ls is passed through here. The other way we can look for help for this command is by using another command called man. Man stands for manual, and the way you use it is you type man and then the name of the command you want the manual for. So if we do that, we get this this very slightly longer, differently formatted manual here. So typing this out will get us to the manual page. Now, I want to be clear, if you don't really know how, if you're really not sure what some of the stuff in there means, don't worry. People who use Unix a lot, the man pages can sometimes be very opaque and very challenging to read. So don't sweat it if you read one and it doesn't quite make sense to you. So the way you exit, if you typed man ls and you don't know how to get out, the way you exit it is by pressing Q. for quit, which will get you out of that manual page. So one thing we should note is if you, so we saw that whole list of flags that ls accepts. If you try to type one and use a flag that it isn't actually a real option, like let's say I did ls-j, I will get this message, ls invalid option j. It's just saying it doesn't know what j is supposed to do to ls. So then it handily says, try ls-help for more information to find out which flags are actually valid ones. So I'll show you back on that man ls page again. You can use the up and down arrows to move line by line. You can use Shift B or the space bar to sort of skip through more quickly. You can search for words in here. So if I type a slash and then the name of a word that I want to look for and hit enter. Well, great, that didn't find anything. Let's try hidden. Great. I don't know why that's not working. Exit. There we go. Okay, so that's what we see here. And then once you've searched in there to move back and forth, you can use the N button to move forward to the next option, or the Shift N button to move backwards. So that's going to help you move through those different things. So if you're looking for a very specific help thing, you can look for it that way in the man page. To be honest, most or all man pages are also on the web, so you can just Google man page ls, and that will get you to the same spot, and maybe in a way you're more comfortable working with. So again, we'll hit Q to exit the man page. So we're going to have you do a brief little activity now. So you can use multiple options at the same time. So we'll have you go ahead and try using the command ls and see what happens when you use the -l option. After that, you can try out what happens if you use both the -l and -h options. So give those a try on your own computer, and let's do the little Zoom like thumbs up response when you are done. What are the reactions we can do? Yeah, do a thumbs up when you're done. Do the little red X no if you need help. All right, so we're going to take a few minutes and just have you give that a shot. I just noticed a question in the HackMD asking what response we get from the shell when we input an incorrect command. I'll just briefly show that again. So if I misspelled ls and I type ks and run that, it will just say command not found. You might also get this if at some point you were trying to run a command, like let's say you are doing something more advanced and someone says, oh, use this, this bit of software. give this a try, run it on the command line. Maybe you haven't installed that software yet. If you try to run that command, it also won't work and you'll get the same thing. It's saying, I don't know of any command with that name. So it's not necessarily that you typed it wrong, but it's that the shell doesn't know what that command is supposed to mean. All right. Okay, so I think we are going to move on now. So I'll show you just briefly what we did here. So the ls-l stands for long. So as we can see, we get out this longer format output. So we get a bunch of different information, including the date of last modification, the file size, the owner, some stuff about the permissions for the file, which is not something we're really going to cover today, and this big old number. So these big old numbers are the file size, but they're often not particularly helpful. So instead, we can use the ls, the -l, and h flags. So one thing to note is we can combine those flags -l and -h into one single one, -lh. So that just says we want to use the L and H options. If I run that, the H stands for human readable, and it will make those sizes a little bit more meaningful. So 1.9 megabytes, 782 kilobytes. I don't have anything too huge in here, I don't think. So those are just, that helps make it a little more readable when you get this output. So we'll do, I'll show you one other flag that's quite useful. So by default, ls will list the contents of a directory in alphabetical order by name. So we can see these X's, W, V, T, those are coming out last. The command ls-t will list the items by the time that they were last changed, time that they were last modified. So if I do a ls-t and run that, now I get some of these, it comes out in a different order, but it's not particularly useful because I would like to see, I'd like to maybe see those dates to confirm that it's doing what I think. So we'll combine the ls-t and L options. So we get that long output, but now it's also sorted by the time of last modification. So if I run that, now I get these where, okay, guess this public directory hasn't been changed since 2009. You know, as we scroll up, we see that these dates changed more recently. My desktop as recently as 11:47 today. So this might not be super useful. I don't necessarily always want to first see the oldest files that I changed. Those are probably not things I'm working with too frequently. So I would like to flip the order that these are printed in. So the command ls-r, the .-r option means reverse. So it means whatever the order that they will print in, it'll just flip it. So we can combine a whole string of these together and do ls-l for long output, t for by time, and r to reverse the time. And then ls-ltr will give us an output like this. So this is a very common command I would use a lot, is just saying, all right, what's in here? And let's see the stuff that's been modified most recently. So that's quite a useful set of flags to use together. Now, so far we've just been using ls to look at the current working directory, which should be your user home directory. But we often want to look at the contents of other directories. So let's try looking at what is contained in our desktop, which is where we put that folder that contains all of the materials for the workshop today. So let's just see what's on our desktop. So we can then pass ls something else. So we'll do the -f option. Remember that formats what comes out with slashes at the ends of directories and leaves files looking normal. But now we're going to give the ls an argument. So an argument is like a broader sort of, not an option. It's not an option that's going to like change the default behavior, but it's saying, okay, what do you want to apply ls to? And we want to do it to our desktop. So I can type out desktop, and what I will now get out is ls, but of all the contents of my desktop. So we see here listed out all of the stuff that's on my desktop. So you can see kind of a mess, but there it is in all its glory. So if a directory named desktop doesn't exist in your current working directory, this command will return an error. So if I typed out f desktop2, let's say I thought there was a directory called that, it'll tell me, can it access it? There's no such file or directory here. I can't find this. Typically, your desktop will exist in your home directory, which we assume is where you currently are. Now, your output should be a list of all the files and directories in your desktop, including that shell lesson data. So I can see that here, right? So I had the zip file that when I opened it, unzipped into this shell lesson data directory. So many, all right, so let's see. So this bash shell, we're kind of starting to get the idea that it's really dependent on this concept of your files being organized in this hierarchical file system. So organizing things in this way is both how our computer thinks about things, and it's a good way of helping us organize our work. So you could just put hundreds of just random loose files into your home directory, just like you could, print off stacks of papers and just have them piled up on your desk or all over your office. But that's typically not a strategy that's going to be helpful for you working from the command line or you just getting work done on your computer in general. So in general, we want to keep things in these nice sort of hierarchical structures. So now that we know that the shell lesson data is on our desktop, we can do a couple different things. So first thing we could do is we could look at its contents in much the same way as we did before by giving that directory name to ls. So we can type out ls-f. Now, I'm going to tell you one little trick that can be very helpful working from the command line in general. It's called tab completion. So typing out sort of these long strings of directories as we get sort of more and more nested can be really easy to put a typo in there. It can just take a while to do. But in general, we can use tab completion to help us get there. So let's say for desktop, I start typing out DES. Now, if I hit tab, there was only one thing in my home directory that started with DES. So me hitting tab, it just said, I know what you want, finish that off with desktop. So now from here, I might want to figure out and go to that shell lesson data folder. So I could right now just type an S and hit tab. Now it wanted me to hit it twice to show it. So I've got a couple different things that start with S. Got the sandpaper docs, shell lesson data, and the shell lesson data zip. So I could continue to type shell lesson, hit tab, it'll complete the data part, but then it's going to say, I don't know which one of those two I want. Do you want the data? Do you want the zip? I just want the shell lesson data, and it would slash there and hit enter. And now what it's going to list out is all of the contents of that directory. So now this is everything that's contained in the shell lesson data directory. Now, this is nice that we can access and work with this other directory, but I don't know that I want to have to type this out, type out this whole path every time I want to work with stuff that's in this directory. So instead, we can actually change the location of our shell. We can say, put me in a different place. So we can navigate to that different directory. So we're no longer in our home directory. Now, the command to change our directory is called cd, which stands for change directory. It's a little bit misleading though. Change directory could, you could think of it as, oh, I'm actually changing something about this directory. That's not quite what it's doing. It's changing where the shell thinks we are. So it's changing the location of where your shell thinks here is. So it's similar to like double clicking on a folder in either the Finder or I forget what the Windows name is, but just like double clicking on a folder where it opens it up and it brings you in there. All of a sudden you're here in that folder. It's akin to that same sort of process. So let's say we want to go into this data directory here from where we currently are. We can do a series of commands to get there. So we can first cd into our desktop, and I'll hit tab to complete that. If I hit enter on this command, now remember our pwd command for print working directory, which is basically saying, hey shell, tell me where you think we are. I do pwd, tells me, okay, now I'm in users MJ desktop. Wonderful. So now I can cd into that shell lesson data. I hit enter. Again, we'll just double check. Great, now I'm here. And finally, I can cd into that data folder that I was in. So this series of commands moved us through these different directories from our home directory to our desktop, then to shell lesson data, then into the data directory. So cd doesn't print anything, which is why we run pwd to verify where we are each time. So we can now we're here, we're in this data folder. We can do some of the same things we did before. We can ask ls-f just to see what's here, tell us what the contents are. All right, so in here, we've got a bunch of different text files. We've got some other subfolders, and they list out where we currently are. So we now know how to go sort of down that tree, right? That hierarchical tree. We can go from the top and we can move our way down. But how do we go up? So how do maybe we want to go back from where we are right now, pwd, in this shell lesson data. Let's say we want to just go up to shell lesson data. Well, we might just try, all right, let's cd to shell lesson data. But it says there's no such file or directory because cd, ls, these different commands, they only know where we are right now. And there's nothing inside this data folder called shell lesson data. It's up a level beyond the scope of where our shell is currently looking. So cd can only see those directories that are inside our current working directory. So there's a little shortcut to move up one level, which is we'll type cd and then ... So ... is a special sort of name, which means the directory containing this one. It's the parent of our current directory. So if we run this cd ... and then we run pwd to check where we are, sure enough, we went up one level to shell lesson data. Now, that ... you noticed if we ran ls-f, there's nothing called ... in here. But we can see it in here if we use another flag to ls. So this flag is called -a for all. So we can do -f and then a lowercase a. The a means show me everything. If I run that, now we get these two other directories showing up, ... and just . So ... means just means up one level. And then there's another one called ... which actually just means the current working directory. So it might seem a little redundant that like, well, we're already here. These commands already know where everything is. But in a little bit, we'll get into why there's also a pointer, this single dot that refers to our current working directory. So you might also have other files that start with a dot, things like .bash_profile, .bashrc. For R, a lot of them are .r profile, things like that. They're generally configuration files and directories that are used to configure things that, you know, typically most people using a computer aren't going to need to interact with, which is why they're hidden away so that, you know, no one accidentally fusses with them too much. Most file systems by default don't show them. So if you're in a Finder on a Mac and you're clicking around, typically you won't see those hidden files or directories, but you can access them using ls-a here. All right, so the three commands that we have, the three commands that we've used so far, pwd, ls, and cd, are like, that's kind of our bread and butter for getting around the shell, for navigating that directory or that file system, that hierarchical tree. These are our tools for navigating and getting around that. But we'll look at some different variations on these commands now. So if we just type cd, nothing happens if we just use cd, but if we just type cd on its own and hit enter, let's check with pwd to see what that did. All right, so I was previously in the shell lesson data, and typing just cd skipped me all the way back up 2 levels to MJ. Well, cd on its own without an argument given will return you to your home directory, which is good for generally like just being able to get back to sort of your starting point of your home directory. It's nice if you ever kind of get lost down in the weeds of navigating through your file system, that you can always get back there quickly. But let's try to get back. Let's say we want to get back to that data directory in our shell lesson data. Well, last time we did cd desktop, then cd shell lesson data, and then cd data. Well, we can actually chain those commands together into one single cd command to say we want to go all the way down this particular file path. So we'll do cd. You can start off with desktop. Remember, I'll do that tab completion to complete that for me. Then I want my shell lesson data. So I'll type that and again, hit tab to get me most of the way there. Hit slash. And then I can tab, right now I can tab one more time and I'll see what's in here. Okay, I want to get to my data folder. So I can type out data. And now I've got this command built up to cd desktop shell lesson data data. And if I run this, you can check with pwd. All right, in one step, we just jumped all the way down to here. Now, if we want to move up one level from the directory, we could do cd ... But there's another way to get to any specific place on your file system, regardless of where you are right now. And that's to specify a path all the way from the very top of our file system. So what we've been using so far are called relative paths, which is the location relative to where you are right now. So that's why when when we did desktop shell lesson data, it said relative to where we are, the path is to go desktop shell lesson data. But we can also specify what are called absolute paths as opposed to our relative paths. So absolute paths are built from the very starting point. It includes the entire path from the root directory on our computer, which is that leading slash. So starting all the way from here. So pwd will print out the absolute path of where I am. which means that it starts with this root directory, that leading slash. So this allows us to move to our shell lesson data directory from anywhere on our computer. We can go to anywhere at one time just by specifying this absolute path. So let's say we just want to move up to their shell lesson data. We could just CD directly into that. So by doing pwd, it tells me the absolute path of everything up till just where I want to be. So now I know that the absolute path to get to shell lesson data, I could just do /users, or sorry, not backslash, I keep saying that, /users, /mj, /desktop, /shell -lesson data. Run that by pwd. All right, we are where I expected us to get to. So we just went up one level, but by sort of specifying all the way from the top of our file system down. So there are a couple more shortcuts to this that we can help that can help us get around a little more easily. So one of them is the tilde character, which typically means the current user's home directory. So it has to start with that. But if I do cd tilde pwd, that gets me back to my home directory as well. Now, I showed you before that doing cd with no arguments given will do the same thing, but the cd or the tilde can be a little more specific about where you want to go. So another shortcut that we might see frequently is dash, which translates to the previous directory that I was just in. So it's a nice way to sort of just go back and forth between two directories quickly, and you don't have to type out the entire sort of path. So I was just in this location, then I went to this location. If I type out cd dash, now I'm back in the shell lesson data. If I type out cd dash again, it takes me back to users mj. So I can just go back and forth between two that may be separated by quite a bit of typing normally if I was going to type out these full paths, but instead just cd dash gets me back and forth between them quite quickly. Got to be honest, this is one that I always forget to use, and I find myself just agonizingly typing things out. So, all right, goal for today, start using this for me more frequently. All right, so we're going to have you do a little exercise as well, which this is sort of on your own. We're going to hold you, Scout's honor on this one, that you are going to not look at the answers prematurely. But on this page that I put into the chat, you can go down to this absolute versus relative paths, which is going to show you an example of, here, I'll just screen share that instead. There we go. All right, so we're going to have you do this activity. So starting from this place called users, Amanda, data, which of these commands would get Amanda to her home directory, which is users, Amanda? So up one level from here, which of the following commands would get her to that location from here? So go ahead, work through these, try to answer them for yourselves, and then you can check the solutions by clicking the drop-down button here and check and see. So clearly there are more than one way to move to different places, but it's often important to understand these various methods of moving around our file system. So I'll go ahead and give you a few minutes to give that a shot. Do again the green yes check or a thumbs up if you get it. And if you run into some trouble, you can throw up that red X reaction. I was muted. All right. We're gonna actually, we'll have you do as well. We'll have you do the next exercise as well. I think the relative path resolution is another one worth doing too. So that's this one as well. Do the same thing. Once you have given this a shot, let us know. You can check the solution. Again, green check or thumbs up when you're done with that one. All right, so we are going to hop back. I'm just going to walk through these briefly, just so we can chat through them a little bit. So looking at these various ways we could get, essentially just various different ways we could try to get up one level from where we currently are. Let's look through which ones of these will and will not work. So cd dot does not work because dot just stands for the current directory. So that would just say, all right, point to the current directory. That will just take us there. cd slash also won't work because that will take us just to the root directory, the most root directory on our computer. Slash home slash Amanda also doesn't work because Amanda's home directory is called slash users slash Amanda, not slash home slash Amanda. For also won't work because it's going to take us to dot dot, which means up one level, which from Amanda data will take us up to Amanda. And then it says slash another dot dot, so up one more level. So that would take us all the way up to users. Now, cd tilde does work because the tilde stands for the user's home directory, which in this case is users Amanda. So that one would get us there. cd home would not work. That would take us to, if inside users Amanda data, where we currently are, if there was something called home in there, it would take us in. Otherwise, it's just going to say, yeah, can't find that one. 7 is sort of silly, but correct. It will say, go to the home directory, which is this, then go into data, which is where we currently are, and then go up one, which, yep, it would get us there, but it's sort of the most roundabout way to do it. cd just by itself will also work. That is a shortcut to go back to the user's home directory. And finally, probably the most straightforward option, cd dot dot, which just means go up one from where we are from here to here. All right. Now, this one is kind of trying to think about helping us visualize these file system trees and where we are and where we, how we can move through them. So if pwd displays users thing, then that would get us to, that means we're currently here. We're right here in the thing folder. Now, ls-f means list the directory, list the contents of a certain directory, and dot dot backup. What will that show us? So we can start off, just start off right here. So dot dot means go up one. So ls-f ... would list everything in users. Now, then dot dot slash backup means we're going up one, and then from there we're going into backup. So ls-f ... backup from here means go up to here, go to here, and then list what's in here. So we should get back original, PNAS final, PNAS sub, which was number 4 on here. So, yep, that would be the correct way to, or that would be what we would get if we ran that command. So navigating these directory structures can be challenging. I remember when I first started using the shell, this was the hardest thing to get, was sort of getting familiar with and comfortable with moving around in this way when I was just so used to pointing and clicking on files and folders in Finder on my Mac. And getting used to this was something that took quite a bit of work, but is important to do. So we will hop back to the, let's see. One sec. I'm gonna share screen again. We will go back to our shell. Okay, so we're gonna do just a couple more things for this lesson, and then I think we'll take a quick break and come back to the next section of the lesson. So we'll talk a little bit about sort of the general syntax of shell commands, because most shell commands take a very similar format for how we will work with them, modify them, and sort of pass information to them. So let's say we've got a command like this, ls-F/. Well, let's break this down a little bit into what the components of this line actually are. So the ls is the command. The -f is an option or flag, and the / is our argument. So we can counter these options. The arguments tell the command what to operate on. So on a file or directory, what is this command actually going to operate on? Sometimes these options and arguments kind of all get lumped together and they're called parameters. But we can generally break them down into these two categories of options and arguments. A command can be called, depending on the command, they can be called with more than one option, as we saw, right? We did like maybe ls-ltr, right? We stitched together 3 different options. And sometimes they can be called with more than one argument. So sometimes you want to work on more than one file. But commands don't actually always require arguments or options, right? Running ls on its own works. It does something. We're using these to modify things. Crucially, on the command line, each of these parts is separated by a space. And this is one of the most common ways that I trip up when I'm typing quickly and typing something out, is I forget to put a space between things and it gets upset with me. So if let's say I was trying to type ls-f, but I forgot that space and I just did ls-f, no space, well, it's going to look for a command called ls-f. Like it thinks that's one word, and there's no command called ls-f. So that's one example of where you might see this syntax error coming up. Capitalization can be important as well. So ls-lowercase s will display the size of files and directories next to their names. So if I run that, we see the size of our various files and directories. And if we do ls-S, it will sort the files and directories by size. We could do both of them together, and now we have them sorted by size and with the sizes printed next to them. So it's important to be careful with how you're typing things out, because that can really change the way that these are it can change the way that these commands function. All right, so putting all those components together, we can say what this command does. So it says we want to list, formatting all of the things listed out with, you write those slashes after directories, stuff like that. And we want to operate on the slash directory, which is our root directory. So if I run that, it's all the stuff in my root directory. Application, system, we've got users, that's where my my home user is. So that is sort of the breakdown of these different components, and understanding and getting comfortable with working with options and different arguments is going to be important when we get to work with more complicated command line tools. So one thing in the lesson that we already actually talked about a little bit was tab completion, because I jumped the gun on that a bit, but I think tab complete is very, very handy, and like to talk about it quickly. So we can check where we're at right now with ls. Now, we're working with this fictional ecologist Nell's data, fictional biologist Nell's data. So Nell has her data organized into this nice folder where she's got North Pacific Gyre, which is where the data came from. And then inside that she has, we can check actually, do ls and start typing out North Pacific Gyre, start nor, and we can hit tab so I don't have to type that whole thing out. So if we list out what's in here, all right, so now we've got this, inside there is this directory with, formatted by a date. So again, we can type out nor, hit tab, and now we can hit tab again, and it'll say, all right, there's only one folder in here. We'll give you that option. And if we run this, now we can see all these different files contained inside here. So tab completion is going to be very slick, very easy. If you structure folders in a nice way, tab completion can work even better, right? Because things start in a certain way, and you can navigate your file system quite quickly that way. So finishing off with that little touch on tab complete, we've hit the end of this first episode of the lesson. We'll go ahead and take a 5-minute break, quick little bio break. If you need it, just get up, stretch, get your eyes off the Zoom screen, and we will return. Actually, let's go a little more. Let's say we will return at 25 after the hour. So we'll take 8 minutes of break. We'll return at 25 after the hour, and Ryan is going to take it away with the next lesson on working with files and directories. So we'll see you all at 25 after the hour.
Okay, so it is 25 past the hour, which is the agreed upon time for us to come back. Hopefully you all are coming back to your computers at this point. I will put the next episode of the lesson in the chat. So we're going to start. So picking up where Michael left off, we learned a few commands. I like thinking of it as we're sort of building out our toolbox throughout this this whole lesson. And what we did right now is we built out our navigational skill set. We can navigate around in the command line, but we haven't really touched any of the files and folders. We haven't made any folders. Like, you can do all of those things that you might use through a graphical user interface, like creating a folder or opening a text editor and making a file. We can do all of that without leaving the command line. And so we'll get into some of that. And let me share my terminal. So let me know if you're having any difficulties with my screen. I made the font size pretty large. And so kind of some of the high level things that we're going to cover in this section working with files and directories. We're going to go over how we can create, copy, and delete files and directories, how we can edit files on the fly without ever leaving the terminal. And we're going to create a directory hierarchy in one of the exercises that matches a given diagram. So you've seen the file hierarchy stuff and what Michael was doing earlier. We're going to try and reproduce that in by using the command line. And we're also going to delete, copy, and move specific files and directories in between each other. So, so we want to go back to our shell lesson data directory on the desktop. And so if I do WD, you can see that I'm in my user, which is our Bartlemy, and I'm in my home directory. If I ls, I have all of my folders and files. If I do the ls-f, you can see kind of a bunch of different executable shell scripts, folders, files. So, but where I want to be is the desktop. So I'm going to change to the desktop, use the tab complete to type out desktop, and then shell lesson data, again, using the tab complete to finish that, because I am abhorrent at spelling things. I make typos all the time. Sometimes when I'm creating directories, which is its own problems. So now that I'm in here, we can take a look again at the contents of this folder like we did in the last episode. You can see that we have these different folders: creatures, molecules, the North Pacific Gyre, and then these different flat files and this folder called writing. So what we want to do inside of this folder for Nell, we're helping her out with her work. And what we want to do is we want to create a new directory. So we're going to do that with a command called mkdir, which is shorthand for make directory. And we're going to call that directory thesis. So I'm going to type that in, hit enter, and you can see nothing happened. It doesn't give you a message saying that it was successful. It doesn't give you a message saying that it failed. It just goes back to the command prompt. But if I type in ls or ls-f, you can see that I now have this thesis directory right here. So super cool, really powerful. And what we can do is we can look at the contents of the folder thesis, and we can see that there's nothing in it. And so what this is telling us is there's nothing in it yet. And we've made this single folder thesis. But what if we need to create, we talked about the file hierarchies. What if we need to create multiple subdirectories inside of the parent directories? So we can use the flag -p with make directory. So -p, we're going to make a new folder called project, and we're going to have data in there, and we're also going to put inside that project a folder called results. So one of the neat things about make directory is you can do a lot of file or rather folder creation all in one line. So what this is going to do with this -p flag is it's going to create the project folder, and inside of the project folder, it's also going to create the data and the results folder. So hit enter, the same thing happens. I don't see anything. But if I type in the ls-f and then r for project, you can see that there are the data and results folders, and the capital R in ls is going to recursively list any contents of the subdirectories. So recursion is a concept that you'll probably encounter the longer you stick around in the sort of Unix terminal world. And what this is doing, what recursion does in any of the commands is it sort of loops through everything and allows you to see more than just the sort of next level. It lets you look a little bit beyond that. And in other cases, it'll let you create things or delete things in batch. Deleting things recursively is, we'll go over that in a bit, is not the best practice. You can do some really horrible things to your computer. It's the most dangerous command that we will teach you, so use it judiciously. And so we have these set of commands, these tools for our toolbox for creating directories. This isn't really that different than using the File Explorer in Windows or Mac OS, or even on a Linux operating or Unix operating system. This is kind of the same thing as going to clicking through the menus and saying File, New Folder. One thing that I do want to stress is that although, like, when you do use the graphical user interface, you have that sort of ability to create a file or a folder that has spaces or weird characters in the name. The Unix command line doesn't particularly like that. And it gets really complicated when you have white spaces in your folder names. And so, like, if we look at where we are, so if I do ls, I'll do ls dash. And so if you look at this right here, specifically this North Pacific Gyre, you can see that Nell has made this folder and it has the dashes in between. So instead of using spaces, Nell used dashes because it works quite a bit easier within the context of the command line interface. You don't want to begin the name of a file with a dash, but what you want to do is use dashes or underscores in place of where you would consciously think about like a space. You can also use periods or full stops in the middle of it. I don't generally do that. Sometimes you can run into issues with different programs interpreting that as like a file extension. So like the extension right here of this text.txt, that's a text file. So putting another dot in there might confuse some programs, particularly if you're using like packages from programming language library or libraries from different programming languages, and you're sort of moving your computing along. It's best practice is to use dashes or underscores. I almost always revert to underscores because visually it really reminds me of a space. So when I look at it in the command line, I see that. My mind interprets that now that I've been doing this for as long as I have as a space. Does anybody have any questions before we move on to like making a text file? We'll get into the sort of the text editors inside of the shell that exist, or specifically Nano. Okay, no questions. All right, so let's change into the directory thesis. So Nell doesn't have anything in the thesis directory at the moment. So if I list that all out, there's nothing there. And so one particular flavor that we at the Carpentries and Thyverse tend to recommend, as it's relatively easy. There are other text editors that people will use, and those are detailed on the Carpentries website itself, like Emacs or Vim. I personally use Vim a lot. I learned a lot of that and the shortcuts with it in grad school. But Nano's a really great sort of user-friendly way of getting there. So if I type in the command nano and I type in draft.txt, what this is going to do is this is within my current working directory, which is the thesis folder that we all created together. It's going to open the text editor Nano and create a file called draft.txt. So if I hit enter, it's going to take us away from the screen, the terminal screen. It's going to bring us inside of new Nano, which is the text editor. So inside of the terminal, there is this text editor, which is really, really cool when you get to the point of logging onto remote computers, like a high performance computing cluster, or like something like Amazon Web Services, where maybe you've uploaded your code, you're about to start working on something, and then you hit an error message and you realize you made a typo. So knowing how to sort of bounce back and forth between these command line built-in text editors, and then creating a file or editing a file and saving it and going back and forth is a pretty interesting and great skill to develop. So if we go through the lesson contents, we're going to say it's not publish or perish anymore. It's share and thrive. And if you're joining us for FOSS, this is philosophically in line with the contents of that course. And once we're happy with that, so you can see that there's these different options on the bottom. So this little caret right here, so that is the control key. So it's the control key. So if I type Control O, that's going to write out to this file. It's going to ask us, is that the name we still want? You can hit enter. So it wrote 2 lines to that text file that we've created with the Nano text editor. And now we're still in Nano. So we kind of want to go back and start playing around with the file in the context of the command line interface. And we can get out of here by pushing Control X. And then that takes us right back to where my terminal was and your terminal was when we invoked the Nano program itself. There's some other options inside of Nano. So if I just quickly open that back, run that command again, and go through a few of those examples. And so what this is going to do is, so if you remember, we did the write out with the Control O, and then we did Control X to exit. So if I run nano draft.txt again, you see everything that we wrote out with the initial Control O is still in there, and the file is the 2 lines that we wrote. So the dash or the Control G will help you with the Nano program itself. So walk you through some of the commands, give you some shortcuts. So there's a lot of different hotkeys for Nano itself. So to access the manual within Nano, we can use the Control G to get to the help menu. And we can use Control O to save the file again, or we can simply exit from where we currently are. So if I do Control X, it will exit from the help menu. I can do Control O to write out any changes that I might have made after reading the text file, and then I can do Control X to leave. So now if I type ls in this directory, we have our draft.txt. So we saw how to create these text files using the Nano editor. So I encourage you all now to go to the file called, or the exercise called Creating Files a Different Way. And so this is going to teach you the touch command. And you might think, like, well, why would I need to do this method? Eventually, you might run into a case where you need to quickly create a file. And so touch will allow you to do that without ever leaving the terminal. And so I encourage you all to work through creating files in a different way. And I will stop sharing for a second and then give you all a chance to work through that next example. And I will drop link in the chat one more time, just to make sure that everybody knows what lesson we're on. I'll give you a couple of minutes. Give me a thumbs up if you created the file with touch, and then I can kind of go through an explanation of what touch is doing. It's kind of a weird little tool for the toolbox. All right, starting to see some thumbs up. Looks like people are getting it. Cool. All right, let me share my screen again. Okay, so what did the touch command do? So if I run touch my underscore file.txt and use ls-l to look at files, you see that it's created a file that has a size of 0. And so interesting, right? So it's 0 bytes. So it has no data inside of it, but we've told the command line to create this text file. And so getting into the why you might want to create a file this way, the solution to number 3, some programs don't generate output files themselves. And so you need to have an empty file to what we might call catch the output, or to take the output of a program and put it into a file to store it. Sometimes, sometimes the Python language does this, where you have to instantiate a file, and then you write out your information into that file after it's been instantiated. We also run into the same thing in the command line interface. And so touch is like just a really quick way. A lot of the times I'll find myself using touch to sort of debug things. I can create quick little files to test a program that's meant to move stuff around or create a file hierarchy and move a file into it, things like that. So it's like making little placeholders that either are going to get output from a program itself, or you're using it to sort of check what the creation of your file hierarchies. And so I kind of touched on this a little bit. So if we go up one directory with the cd ... and then I do ls-f again. So one thing you kind of noticed, and I touched on, was the like .txt or this .cfg or the .pdf. So everyone, I think, at some point, through using computers, even through a graphical user interface, you can run into these file types, right? So you have the text files, which have the extension .txt, .pdf would indicate like a PDF document. When you get into more of the sort of exotic files that you might find in the command line, like a config file, that might be .cfg. So this pizza could be the configuration of Nell's pizza ordering script. If you're staying late at the lab, maybe Nell's automating the ordering of pizza if she's logged into her terminal after a certain time of day. Who knows? And then PNG is an image. So this is a convention, and this is directly in the notes, and it's an important convention. So files contain bytes, and it's up to our programs to interpret the bytes within those files for their specific format. So what the file extension is doing is it's telling your computer system that when you access a text file, it should open your default text editor if you're using the graphical user interface. Kind of the same thing that happens with here, like inside the command line interface. If I tried to open a PNG file in Nano, it's going to look like a bunch of crazy characters that don't make any human interpretable sense because it's an image file. Same thing as if you say took an image of a whale that's a PNG file and you change the file extension to .mp3. It doesn't magically turn the photo of the whale into a whale song, but it might try, if somebody moves your file in a GUI, to open the like whale.mp3 as a music file. And it'll return an error from the graphical user interface because the file extension doesn't match what the operating system expects the contents to be. Hopefully that all makes sense. Does anybody have any questions? So we got through file creation. So we've made directories, we've made some files, put a few more commands in our toolbox like nano and touch and mkdir, and sort of going back and using ls and pwd while we're moving around and creating things to check where we are. Does anybody have any questions? Feel free to drop those in the HackMD or unmute, ask me directly. Otherwise, we'll move on to the next section of this, which is moving files and directories. So not moving between them, but physically moving them on the file system. Where we are, we can do CD and then the tilde desktop. I'll type this out even though we're already there, just so that we're following along with the lesson itself. Thesis directory, we have that file that we made with Nano called draft.txt. So that's not a very informative name. So what we can also do with this next command, which is mv, which is short for move, is we can use it to rename files. So the first thing we're going to do is we're going to take thesis. So this is a directory, right? We're doing this one level down. So we have to tell the command line what file we're renaming. The second argument is where it will go. In this case, what we're doing is we're moving thesis, the draft.txt from the thesis folder into a new file called quotes.txt, which has the same effect as renaming the file. And if we go myfile.txt from touch, and quotes.txt is here in place of our thesis.txt. And so this move command, it's something to pay attention to. Any existing file with the same name. So if you had another text file in that same folder called quotes.txt, move would not care at all that you specified quotes.txt. It's going to take your argument literally because it's a machine, and it will overwrite what was in quotes.txt with the contents from thesis.txt. So one option you can do with move is the -I, which is interactive. And so what this will do is this will ask you whether or not you want to do something. So if I wanted to, say, go quotes.txt, and I want to rename it back to draft.txt, okay, didn't give me anything, right? Because there's no competing file, right? It's everything, the arguments didn't run into an error. And so if I repeat that again, I can rename it. So you can scroll back up in your history with the arrows. So I want to go back here. Just do this. Draft.txt, thesis, quotes.txt, and turn that back. All right. So if you run move with -I, it's going to ask you the sort of the same prompt that you might get out of a graphical user interface of, are you sure you want to overwrite this file? And so that's a nice little stopgap. And so let's say we don't want our quotes text file in the thesis directory. We decided that we want it where we currently are in the shell lesson.data. So we can use some of the shortcuts that Michael was talking about with the orthogonality of the operating system. So we can move the thesis/quotes.txt, and we can put a period. If you put a dot at it, if you remember when Michael was talking about hidden files and folders, this stands for current working directory. So since the command line has that already in it, sort of hidden away from you, what this will do is this will take our quotes.txt when I push enter, and it will move it from the thesis folder into our current working directory, which is shorthand, the dot. Using the dot as shorthand, it will be something that will probably come up quite a bit for things you do in the future, where if you want to run a program and you want to run it in your current working directory, a lot of the times they will take that that dot, that shorthand reference. And so if I go and list my thesis directory right now, you can see that there's only the my_file.txt that we made from the touch command. And if I ls in my current working directory, -f, you can see that quotes.txt is now here. If I try and look for it where it used to be, so if I do ls thesis quotes.txt, you'll get an error. Another quick way of checking this before you get an error is if it will tab complete. If you push the tab and nothing happens, and you keep getting an audible ding, and that happens in the Mac OS when you can't tab complete something, it means the file doesn't exist there. It doesn't exist in that path. So if you type it all out, you'll get this ls, no such file or directory. But if you're using the tab completion pretty regularly, you'll hear it if you're wearing headphones like I am, or you have your speakers unmuted, that you can't tab complete it, which means that it doesn't exist. Okay, and so the next exercise that we will do, I'll give everybody a few minutes to complete it, is the moving files to a new folder. So we have this sucrose.dat and maltose.dat files, and we want to find them. And this is actually, didn't explicitly say where this was, but I know that this is in the molecules folder. Molecules. Files have been placed in the raw folder. Michael, do you happen to remember where the files are for this example?
Sorry, for which part?
Moving files to a new folder. So they should have been placed in the folder raw. Well, regardless, the solution is more of a fill in the blank question. So like this is more of a sort of what would the syntax of the command be to move them all into the raw folder itself. So someone asked in the chat, can we have a command line to move ahead instead of back up to the parent folder? So if you do CD and then you push the tab button, it should list out any of the directories that could be your change directory target.
Well,
no, you can't use the shorthand to move up one directory, because what if there are multiple directories in that folder? There's no specific shorthand for moving up one directory, right? Because your current working directory could have an infinite number of other folders. Well, a finite number equal to the amount of space on your hard drive, but hypothetically an infinite number of folders. So, you know, the reason that doesn't exist is because of exactly what we were talking about with the file hierarchy trees. So you're moving through a sort of a bifurcating tree as you keep going and going and going down into the different subdirectories. So you only have the sort of shorthand for going up, backwards towards the root, up a level. You can go up 2 levels if by doing the ... and then a / and then a ... Then a quick little trick. All right. So let me share my screen. And I will just move this over here. So the solution is to move it by using the ... / raw. So that's referring to the parent directory. We're going to move it from the parent directory to a new folder called raw in this example. So now if we go back to, I just clear, so we can start with a fresh terminal. And so if I list what we have in here, so we have our quotes.txt. So let's say we want to copy, which works similar to move, except it's going to make a copy of a file instead of moving it. So it's going to copy the file in place into a destination that we specify. So the first argument is the file that we want to copy. So that's quotes.txt. And we want to put that in the thesis directory, and we want to store that in a new file. And we're going to call quotations.txt. And then if I do ls text, quotations.txt. Okay, you can see that both of those files exist when we invoke the list command. We can also do things with the copy command cp recursively. So I mentioned recursion earlier. This is a quick little way of, we're going to make a backup of our thesis folder. So I'm going to do cp-r, and we're going to take thesis, the first argument, and we're going to make a backup of it by copying it, and we're going to call this thesis_backup. So now if I ls, you can see that I have thesis and thesis backup here. And if I list thesis and thesis backup, you can see that thesis contains the files, the my_file.txt and then quotations.txt, and thesis backup has the exact same files. So now we've got a few more sort of exercises to check to make sure that I'm explaining this well enough. And those can be found, same link. So that's the renaming files and moving and copying. So these are, again, sort of decision-making questions where you're looking for what's the best syntax of the commands for both renaming files and moving and copying. So I'll give you all next maybe 2 minutes to sort of look through that, and then we'll get into removing files, and then we'll end with wildcards and operating on multiple files before we go into a brief introduction on how to find things. We might not get through that whole lesson today. So again, all of these materials are freely available. So if you want to come back, revisit something that we talked about, it's a little confusing, and we can You can also go through and work through these materials. Carpenter provides all the answers within each of the episodes, and there's pretty deep explanations. This whole Shell workshop is meant to be probably about 5 hours in person. So we're kind of cherry picking enough to get you started. All right. Take a look at some of the solutions for this. All right, so we have our quotations and thesis backup. So if we run through this, suppose you created a plain text file in your current directory. It contained a list of statistical tests that you would need to do to analyze your data. You named it statistics.txt. After creating and saving this file, you misspelled the file name. You want to correct the mistake. Which of the following commands would you use to do so? Copy, move into the current working directory, or copy into the current working directory. So we go through this. No, the first option would create a file with the correct name, but the incorrectly named file is still going to exist. Also going to kind of slow down your tab completion if you're really working quickly. And you still would need to delete the file. The answer 2 is the correct one. So that's taking your misspelled statistics.txt and fixing the spelling by invoking move to rename the file itself. And neither of these move or copy into the current working directory will work because the file already exists. So you're providing an argument telling it to do something in a folder where that thing already exists. So nothing will happen. It's identical file names can't be created. So the last moving and copying question. So this kind of walks through some of the tools we've learned over the course of today. So we have PWD for print working directory. It's going to put out where this person is. They're in this folder called data. It's going to list proteins.dat, and then the person is making a directory called recombined, and this is moving the proteins.dat file to the recombined folder, and then copying the proteins.dat file into the proteins.save.dat up one level from where you currently are, and then it's going to list. And so if we walk through the answer for what the ls output would be, the 2 is the correct answer, because with this ... that's telling us to copy that file up one level. So that's not putting it in our current working directory. That is putting it into the folder users/Jamie. And the same thing for option 3 for the answer, and the same thing for option 4. So now we're going to move into removing stuff, and the warning in this lesson for removing always comes after doing it. I like to go through this before even talking about this, because this is this can be a very, very destructive command with improper syntax. So where is that? Deleting is forever. I want to emphasize that. I'll say it again. Deleting is forever, and I'll say it a third time. deleting is forever. This is not like dragging something to the trash bin on your operating system where you can go in and you can say, oops, I would like to move this back to where it was. Please restore it. RM does not care. It does not care that you made a mistake. RM is a greedy command that wants to destroy everything in its path. It wants to remove whatever you put in its path. And so if we start off, and so we've made, so if we dive into this example, now that I've said deleting is forever 4 times. So if we want to move back into this list, let's say we want to go into our thesis folder, and we're going to list that. And what we want, actually, hold on, let me go back. Apologies. Let's go back up one directory. So we'll list this. We want to get rid of this quotes.txt file. And so this quotes.txt file is here. We've already done some copying. We've copied this. We've renamed it into quotations. It's in our thesis and our thesis backup. We know with absolute certainty that we no longer want this file in this particular folder. And that is when we reach for RM. So we're very certain that we want to get rid of quotes.txt. You can be extra sure by always using tab complete, so you can see that you're deleting the correct file. You've spelled it correctly. It's not something that's important. You're not going to accidentally delete your entire program that you've written or anything like that. And so I'm going to run this rm quotes.txt. Now, if I do ls quotes.txt, no such file or directory exists. Cannot access it. And so deleting is forever. And that's the count of me saying that is up to 5 now, if you're keeping track. And so if we want to use RM safely, and this, I'll just walk you through this. This is an exercise in here, but for the sake of time and expedience, I'll just walk everybody through this as a group. So we do RM-I, and then we want to say thesis, backup, quotations.txt. It's going to ask remove thesis quotations.txt. And if I type no, or just N and hit enter, it will not remove it. So now if I do ls thesis backup quotations, it's still there since I said no. So if you want to use RM in your standard practice and you feel absolutely terrified because I've said deleting is forever 6 times now, use the -i flag. Use the -i flag. It lets you look at it one last time before you say, I want to delete everything forever. Also, if you continue up forward in this is an aside, this is a mistake that I made as a graduate student. If you continue on in the carpentries lesson, you get into the shell scripting thing. I wrote a program in graduate school that used RM inside of a loop, which is not a good idea. That is a terrible idea. That is how computers get destroyed, by the RM command. This is the one command that we're teaching you that could quite literally delete your hard drive. One of my closest friends here at Tucson, well, not in Tucson anymore. He moved to another university. He's an HPC, high performance computing system administrator, and he said that he's probably deleted his laptop accidentally with RM about half a dozen times. It happens to people that this is their livelihood. My RM story is I wrote a recursive loop to remove all of the intermediate files that were generated by my program, but I specified it with what we'll be getting into next, which are wildcards, And so it ran through, deleted all the intermediate files, and then it deleted itself. The program no longer existed because somehow I managed to write a loop in such a way that the program ran, the loop finished, and then it deleted itself. So RM, very powerful, use it with respect. So getting into the next sort of suite of things you can do with RM. So if I want to remove the directory thesis because we've already made a backup of it, it's fine, I don't need it anymore, I'm gonna just blow it all up and start over. I get an error message. So it's telling me thesis is a directory. And that's like not really an informative error message, right? Like if you want to remove something, you should be able to remove something. And so what's happening is that when you try and remove a folder, you need to specify that you want it to use remove recursively. So if I do rm-r and don't hit enter with this, don't put any other things in here, type this out, tab complete it to thesis. And a better practice might actually be to add the -i flag in here as well. So we do rm-r-i thesis. This is going to say, would you like to examine the files? Yes. And then it'll ask you individually for every single file in the directory, do you want to remove this? Yes. And yes. And then do you want to remove the directory thesis? And then I'll type yes. Now, if I hit ls, you see that thesis is no longer there. All of the contents of thesis are gone, but we still have our thesis backup folder. Using RM is another reason why you might want to make backup copies of the files and folders on your computer, because now that you know enough to be dangerous, you can get yourself into situations like I described, where suddenly you no longer have anything on your computer at all. Does anybody have any questions after I hopefully thoroughly scared you into using RM responsibly? All right, no questions? I will move on to copying with multiple file names. So we're going to get into the section where this part is more, I don't want to say realistic, but it's more of a real world type of scenario. Working with single files, single folders, you'll probably start doing that, but at a certain point, you're going to hit this, you just want to do things quickly. And so I want to create a directory in here called backup. So I'm going to create a directory called backup in this folder that I'm in right now. Okay, and then so now I have my backup folder created right here. And excuse me, I did that incorrectly. So I'll use rm-r-i on backup. Yes. Yes. So I'm going to change in the data directory. It helps if I read before I continue and start talking and teaching. So now I'm in the data directory, and I'm going to list the files in here. Okay. And so I'm going to make a directory inside my data directory called backup. So I'm going to back up a few files, and I'm going to use the copy command to do that. Use the amino acids.txt, the animals.txt, and I'm going to specify backup. So what this is going to do is it's going to copy more than one file into the directory backup. So if I do ls-f, you can see that amino acids.txt and animals.txt are still here. They're still in this directory, and that's awesome. And so when you give, and this is working through this solution, if you were to give this amino acids text, animals text, and morse text, and you push the copy command, you're going to get an error message that says target. It's on my particular computer, it's saying that the target needs to be a directory. So this is giving me sort of a shorthand of what Michael showed you earlier with the man pages. This is giving me or the -H. So morse.txt is not a directory, so we can't copy anything. So that's working with copying multiple files into the same folder. So what if we are interested in, say, multiple files that have a similar name? And this is probably the thing I do the most when I'm doing some of my sort of bioinformatics data science work, using these wildcards. This is a huge time saver for doing this sort of stuff. So if we move into the molecules directory, okay, so if we do ls-f, you can see that we have all of these different .pdb files. These are molecular, 3D molecular structure files. And so if we want, we can start using ls with stars. So the star is called a wildcard. So that'll match 0 or more characters. And so, for example, if I do ls star ethane, .pdb, it'll list ethane and methane, right? So it doesn't care that ethane doesn't have anything before it, and it's also matching methane because we put the wildcard there. So we can also use question mark for exactly one character. So if I do the same thing and I do question mark ethane.pdb, it only matches methane, right? So the question mark is a placeholder for a single character. Star, the wildcard, it's 0 or more characters. It doesn't care. And so if I were to do this ls again, and I do 3, and then put ane, the suffix of the molecule, it's going to list all of the molecules in here that have 3 letters preceding the suffix. So it's not going to list methane. It's only going to list cubane, ethane, and octane, because all of those have 3 characters before ane.pdb. So when the shell sees these wildcards, it's expanding it to create a list of matching names, file names, before running the command that we asked for. If the wildcard does not match any file, bash will pass the expression as an argument to the command as it is. So like if I'm within this molecules directory and I type in ls star.pdf, it's going to give an error and it's going to tell me no such file or directory. Generally speaking, ls will see these commands. But this is all dealt with in the shell. So I talked about orthogonality before, and that's exactly what's happening here. So this is taking your ask against the file system, and the shell is saying, okay, I'm going to pre-populate this, and then I'm going to tell you. And if I can't tell you, I'm just going to tell you that it doesn't exist. There's another exercise in here that I'm going to skip over, where it's playing with wildcards and substituting, looking for the different files that would match in this directory based on your wildcards. So I can just go through, I'll just go through example 1. So if I do ls*t any.pdb, it's going to give me pentane, octane, methane, and ethane. So this is going to show anything that has the letter T in the middle of it, and ends with the suffix ane and then the file extension .pdb. And so you can play around with some of these different. I'll do one more just for the sake of examples. Right. So if we do the *t any .star, it's going to list octane and pentane because it's looking for 0 or more characters before the letter T, then a single character, and then NE period. And then by putting the star at the end, that's telling us we don't really care what the file extension is. Just list anything that has this sort of syntax that we put in. So someone asked, is it possible to use move for multiple files alongside renaming them? I don't believe that move accepts wildcard characters. It's very explicit in the syntax, but feel free to correct me if I'm wrong, Michael.
I think that's correct, because there's the issue is you are, yeah, you would be pairing, you have to pair essentially like the old file and what you want it moved to, which would be a renaming of it, but those need to occur in those pairs. So there's not really like an easy way to just say, move them all here, then do this, then change them as you go. You'd have to get a little fancier with it and perhaps do a loop. Which,
yeah, and another thing too is like it might be like a better solution for that might be if you you reference the copy command. So if you wanted to, you could move multiple files or copy multiple files rather. Let me use the proper phrasing. You can copy multiple files to a destination using wildcards. But that's different. You're creating another version of the copy. What move is doing is it's directly altering the files, and so you have to be explicit. So it's kind of a stopgap so that you don't accidentally like rename all of your text files in your directory to be the same thing. Because again, that's an art, like earlier today, we found that that's something that is not possible. You can't have this, you can't create the same thing on top of the same thing. It's going to throw an error. Okay, and then I think Michael, I think I'm going to stop there so you can give everybody a quick little tutorial on the find command. So the last command we'll go over, Michael will go through the find command. So this is a great command if you have forgotten where something is on your file system. You'd be surprised how frequently that happens, especially as you start moving to working on remote computers. So you move off of your local computer onto a server, and then you're like, oh no, what did I call that folder? I know the output file is this text file, but like, where is it? How can I find it? So Michael will go through that. And for anything that we didn't cover today, there are those reference materials through the carpentries, and do feel free to work through that. Especially if you're feeling hungry about learning more Unix commands, it's probably the most digestible way of learning, going through those carpentries materials.
Yeah, yeah. So I really recommend, I think our focus here today was to try to really drill in familiarity with sort of this different way of working from the command line, because that's the hardest thing to get a feel for. In my experience and the experience of most people I know who have learned the command line, is this stuff is the most difficult to get. But once you sort of get a feel for how these things work, building to the more advanced stuff is certainly easier. So yeah, so I would recommend, if you're interested in this, if you feel like you want to learn more, finish off the other parts of this lesson before we before too long. Don't let it go too long while this is all still fresh. I would highly suggest doing that. So we are going to now switch to this section of the lesson, but we're actually going to scroll down until here. I'll share screen just to show that. We're going to scroll down to this part, and we're going to start here. So it's down about halfway to here. We're going to start. So the portion that comes before this is using a command called grep, which is used for finding different things within a certain file. But most of what we've been doing today has been working with sets of files and with directories. And so we're choosing to stick with that a little bit more. But if you want to learn a little bit more about working specifically with different files, you can go in and read the rest of what we didn't cover today. So we're going to be focusing on the find command, which is very useful. It's sort of similar to ls, but has some slightly different functionality that will be useful to you. So I'm going to share my terminal again. All right, so here we are. I'll clear this. So I'm currently in the shell lesson data. Now, find helps us find files themselves in various places on our computer. And it's got a lot of different options, but we're going to go through some of the simpler ones right now. So we're in, let's do lsf just to check and see that we know what we're working with here. So we're actually going to move into the writing directory. So I'm going to cd to writing. And again, we'll ls what's going on here. All right, so we have 3 directories: data, thesis, and tools. And then we've got this haiku.txt just listed out right here. So thesis contains an empty file called emptydraft.md. Data contains 3 files: littlewomen.txt, 1.txt, and 2.txt. And the tools directory contains programs format and stats, and a subdirectory called old that has a file called old tool in it. Sorry if you hear my dog going crazy. Someone just showed up at our house. So for our first command, we're just going to see what find does if we say find dot, which, as we know, dot refers to the current working directory. So find dot will say find what's here. So if we run that, this will give us the relative paths of everything here. So you'll notice that it's slightly different than ls. If we did ls, which is essentially the same as ls dot, it just gives us the top level of what can be found in this directory, whereas find will dive into each of those and find like the end point of each one. So it'll say, okay, first thing I found that starts with dot is dot. current directory. Then there's a ./tools directory. Inside that, there's this thing called ./tools/old, right? So it's basically going in and finding everything contained within each subdirectory, like all the way down that file tree. So it's finding, you can think of it if this is like a hierarchical, those tree diagrams, it's finding that every single tip and showing us those. And it's showing us every node leading down to those as well, right? Every directory itself gets shown too. So the first option we can use to get this maybe a little bit more usable for us, or a little more helpful. It's not always necessarily useful to just see everything like this. So the first thing we can do is we can pass an option. We can do find dot, and then we can give it a type flag, and we'll pass that flag the option D. So what this is it's saying find here things of the type D, which is type directory. So if we run this, it'll find all of our directories. So that includes the current one, the dot. It finds tools, finds within tools a subdirectory called old, and finds thesis and data. So they're not listed in any particular order, unlike ls. That's one thing to note. If we change, let's say, find dot, and we do type, instead of D for directories, we do F for files, we'll only find files. So it's only going to find, it's not listing out, right? Even though it gives us the files with the relative paths that include the directories, it's not matching the directories themselves. So, all right, this is nice. It's getting us some ability to, within maybe an entire project, right? Within our whole data shell project, we can find various things within that whole thing. So now we can match by, instead of file type, perhaps we want to match by name. So we do find here, we'll give it the name flag. And to that, we will pass *.txt, right? Doing one of those wildcards. So if we run this, well, that's kind of odd, right? Like there are these text files. Why didn't it find these text files? It only found the haiku.txt. Well, this is because the shell actually expands this wildcard before it runs the command. So when we're thinking about wildcards like this, essentially what happens is this gets expanded in our current directory. And the only .txt file in our current directory is the haiku.txt. So essentially what we did is we ran find dot and then -name.txt. But this gets expanded before the command completes. It gets expanded to just match haiku.txt. And if we run that, sure enough, that's what we get. So that's what the command actually ran was. Find did what we asked. The find command did what we asked it to do, but we sort of asked it not exactly what we wanted to get out of it. So we can actually change this slightly by modifying how this wildcard gets expanded. So we can write out type or find dot, do -name, and then we can actually wrap our wildcard statement in quotes, which will prevent the shell from expanding it prior to running the command. So what will happen now is it will say find, it'll run it, and then it will assess, okay, now what's the wildcard, instead of expanding the wildcard before it even runs. So if we do a quote and then *.txt and then close that quote, if we run this, now it finds all of the .txt files, recursively within our whole directory here. So this is very important. I always, it takes me like 1 or 2 times every time I'm writing on the command line to remember the correct way to do the wildcard expansion. So just know that the quoting a wildcard like that is something you might have to do pretty frequently. As we talked about earlier, the command line can be really powerful in the ways that we can combine tools. So I'll just show you one useful little thing for why we might want to, for example, find all of these files and how we can use these. So what we get back here is this nice set of files, and we might want to do something with them at some point. So there is a handy little command called WC, which what WC does is it gives us the word count. So I could do WC haiku.text, and it'll tell me some information on the number of, I think it's characters, maybe lines, words, and then characters. We can pass it a flag -L, which says, just tell me how many lines are in this, are in here. We run that, it'll tell us, yeah, there are 11 lines in haiku.text. Now, this can be useful for seeing, how long various files are, and it's maybe an example of just showing you how you can extract information from a file in this way with a command line operation. But sometimes we might want to pass it multiple files at once. Well, it's pretty handy, but this expression, or this command that we ran, gives us back a list of files. So maybe we want to pass that on to our WC command, so we get the number of lines for each of them. So we can use this powerful little thing, which is an expression that looks like this. So it looks like our prompt, $, and then 2 open and closed parentheses around it. And what this will say is basically run everything inside of here, and then that will expand to give us our result back, and we can do stuff with that result in the same line. So how this would actually look would be, let's say we want to run the word count command. We want to do -L to give us back the number of lines. So as we saw, we could just do that on a single file, haiku.txt. But let's say we want to do it on all the text files in our whole directory. Well, what we can do is we can do this $, open close parentheses, and then inside there we can put that find command in. So we find -name, so we're matching by name, and then in quotes *.txt. So what will happen is this is telling the shell, run this whole thing first, then the contents of this result give to the WC-L command. So if we run this, we get out, it finds all of the .txt files first. It's the same set that output just from that command on its own. Then it passes all 4 of those to the WC-L command. And then we get these, we get the line numbers. So 11 lines in the haiku, 300 in data.2, a whole lot, 21,000 some in Little Women, and 70 in 1.txt. So finding files in this way is really powerful. This is sort of the concept that we don't really have a ton of time to get into today, so we're not gonna drill it too much. But it basically, this is starting to get into the idea of from the command line, it can be very powerful that we can use one command to get a bunch of files, and then at the same time run something on all of them at once. Now, this is something that's pretty common across a lot of languages, right? In R and Python, in basically every programming language, you can operate on multiple files, objects, whatever, at one time. But being able to do it very naturally, very easily with our the same way that we would navigate our file system, being able to, from the command line, work with multiple files in this way is a really powerful approach. So that actually about covers the stuff that we wanted to talk about with find. The rest of this particular part of the lesson and the rest of the lessons in general do a lot more dealing with sort of this iterative process, do a little bit more of linking together these various, like how can you string together different commands at once that allow you to chain things together in a more powerful way. And also gets into loops, into how to loop through multiple directories, files, multiple inputs, and do the same thing many times, so you're not repetitively pointing and clicking to get your work done. So I think this is the most natural stopping point we have. We've got a little over 10 minutes left. So I think what we'll do now is we can just field any questions that you have. Obviously, you can feel free to put them in the HackMD here. Feel free to ask them out loud. Anything that you're particularly interested in that you want to know a little bit more about, we are more than happy to help you out here. Just at this point, we're not gonna get through too much more in a way that's going to be particularly useful and not just rushed. So happy to field any questions. Brian and I can both tackle those. So yeah, feel free to ask away. I guess what I'm saying is if there are no questions, we'll feel free to call it today. For those of you who are also going to be seeing tomorrow at the Git lesson, look forward to seeing you then. But otherwise, yeah, just feel free to ask questions. Sorry, I'm not sure what you mean by pipe head. Ah, okay. So yeah, so this is one of the topics that's addressed more broadly, or addressed elsewhere in the lesson. So in the pipes and filters part of the lesson, we'll learn about, you can learn about pipes, which are a slick way to utilize multiple let's see. Yeah, so I'm just pulling up the example because there is a cool one using some pipes to look at various things. So I'll show you this example. So if we go into molecules, we can do wc-l, and we can run that on all of our .pdb. So we get back the line counts of all of these. We can use a pipe to say, all right, send all of the contents here into, we could use the head function. And we could say, give us the first 3. So head will give you the first n number lines of any file. So if I did head -n, or if I did head of Cubane, this would be the 5, or I guess there are probably only 3 in here. so this give me the first, n lines. Sorry, not the text inside. So one to do would be, well, so when you're building up these pipes, what you're going to end up doing is whatever comes out, whatever the output is here is what gets passed to the next command. So we could do this, we could pipe that into, let's say, sort, which will sort according to, that will sort these according to that first component, the number of lines in there. And then we could pass that into our head function. And let's say get the first three. So the three shortest of these files is essentially what we're doing here. So yeah, so that's how you might use WC in conjunction with the head function or head command.
So Michael, somebody asked me in a direct message in the chat, and this is kind of a good tie-in with this. So you demonstrated the sigil, the $ with the parenthetical to encapsulate that command, and then operated on it with the WC-L command. And so this person had asked me, so what's the difference between doing that and using pipes? And I think this is a good time to sort of talk about this. If you go through the shell scripting episode, the sigil or the $ with the parentheticals is a better practice when you're writing out a script, but you could get the same solution both ways if you're doing a one line in the bash terminal itself. You'll get the same answer. Pipes are used to take the input of, or the output of one thing and put it in as the input of the next, and so on and so forth, every single pipe that you see. But if you wanted to combine commands into a reproducible part of a script that you're running, it's better practice, the best practice, to use the sigil, the $, and the parentheticals to encapsulate the command that you're typing.
Yep. That is yes, that is a good one to talk about. So yeah, because and there are times where it doesn't work quite the same way as we might see here. So you can't necessarily just swap them in and out, right? Or unless I'm just swapping them in and out incorrectly.
Yeah, so it's a very like case by case basis for that. Using the $ and the parentheticals, it also changes depending on like what programs you're referencing. It's like it's nice shorthand for essentially it's creating a variable out of it, like a temporary variable, and then the shell is seeing that temporary variable and they're doing a thing with it. Hopefully that didn't confuse the heck out of everybody.
Going down the rabbit hole with this stuff can get very yeah, you can get pretty out there pretty quickly, but I think what we covered, I'll say this, so what we covered today is like 80 to 90% of what I do in the shell ever. Is like you will spend more time CDing, LSing, and MVing than like anything else. These sort of commands are super crucial. These are the ones you'll use basically anytime you're working on the command line. Everything else is a little more specific, case by case basis. But if you log on to an HPC at your institution, you're going to be LSing and CDing and moving around your file system in that way. So this is the stuff that you really can't do without. So really getting a good grasp of this is going to make learning those other components the more maybe powerful stuff, much, much easier.
Yeah, and I think like for like what Michael just showed with pipes, I think one thing that I frequently do is count output files. So like there's Michael has the .pdb files. So if you do like ls-l and then star .pdb and then pipe that into wc-l, it will count the lines from that ls, and it'll tell you that you have 6 PDB files. So really, really nice if you're working with hundreds or thousands or tens of thousands of files, and you're like, I know I should have 10,000 outputs from this program because I'm processing 10,000 things in parallel. And if you don't get that when it's done running, you know that there was a problem, right? It's a nice little sanity check. So on top of what Michael was saying about move and CD and making directories, this is probably like the pipe syntax I use the most with the wildcards and the file extensions to check to make sure that I have my inputs and outputs are correct. And there's symmetry between the two. I'm not losing information.
Mm-hmm. Yeah, that's a big thing that is really useful about a lot of these tools is we've been working with relatively small sets of data here, but all of these things scale really well. So you could go from, it's pretty easy for us to just look at, that molecules directory, pretty easy for us to just ls that and look at them. And we can read all 6 of them and see what they look like. You do try to do this with 6,000 of them, good luck seeing if one's missing. Good luck seeing if, trying to scan through manually and see what's happening. So thinking about a lot of these skills that we learned today as things that scale really well, regardless of how big your project gets, that's one of the most powerful things about these approaches. And that's also when things like tab complete start to come in really, really handy. Because if you have, 100 directories inside your current folder and you need to CD into one of them, well, trying to scan through them to find the right one can be kind of frustrating. Tab completion is a way to sort of help you navigate that. So yeah, a lot of these skills are really going to come into play when you're working with much bigger projects, but they'll scale up to that level very, very easily. All right, you want to tackle this one, the double pipe? I always forget what a double pipe does.
All right. Somebody asked me in a direct message where will the video recording after the session be found. So it'll be found on the AG2PI website, ag2pi.org. So it's ag2pi.org. And there's a YouTube page linked on the workshops page. If you go into this specific workshop, there'll be whenever that video is done processing, it'll be up there.
Yep. Love waiting for YouTube to process stuff, but
yeah.
All right. Well, I think that is about all we've got for today. Thank you everyone for taking the time to show up and listen to this. We hope this was beneficial to you. For those of you who are doing the Git session as well, we will see you tomorrow. And for all of the future FOSS attendees, we'll see you the next 10 weeks as well. So yeah, keep an eye out for that on AG2PI. We'll also put the link into this HackMD. So if you have the HackMD link still, we'll put it there as well. But yeah, have a good one, everyone. Take care.
Thanks, everybody.